Alright, so these are problems that are asking us to solve the systems of equation using substitution. So we're going to substitute the value of something in one equation for the other. And when I look at these equations, or at least the first one here, I see that I have here y equals something, in this case 4x plus 4. And here I have y equals something else, in this case negative 2x minus 2. And if the systems of equation is going to be solved, then the y in the solution is going to be the same. So in other words, this y is going to be equal to this y. So if these y's are equal, then what they're equal to, 4x plus 4 and negative 2x minus 2, must also be equal. So using substitution, I could say that 4x plus 4 equals negative 2x minus 2. So now I can just solve for x. I can do so by, if I add 2x to both sides, I'm going to get my x's on one side. These are going to cancel. So here I'm going to have 6x plus 4 equals negative 2. If I subtract 4 from both sides, now I have getting rid of that one. So now I've got 6x equals negative 6. And if I divide by 6 on both sides, I get x equals negative 1. Now that I have that, I can come back into one of these equations and find out what y is. So we'll do it with the first equation, which I'll put in red, this one right here. Okay, so if x equals negative 1, then if I have the equation y equals 4x plus 4, that's the same thing as just saying, well, that's the same thing as y equals 4 times negative 1 plus 4, which would be equal to y equals negative 4 plus 4, which equals 0. So here we have y equals 0. Now I could do, if I had chosen the other equation, this one right here, you'll see it won't matter because it's the solution is going to be the systems of equations. So if I did it right, and we'll do it here, so we have y equals negative 2x minus 2. And in this case, that's going to be y equals negative 2 times negative 1 minus 2. That's equal to 2 minus 2, which equals 0. In both cases, we have y equals 0. So it didn't matter whether I chose this first equation, which I did in red, or the second equation I did in blue. But we know the solution is going to be x is negative 1, so negative 1, and y is 0. So my solution is the point negative 1, 0. For the second equation, it's very similar. We have a y here and a y here, and they're going to be the same thing. So if I just substitute this value here for this y there, I end up with the equation negative 3x minus 4 equals negative 4x minus 5. So now if I add 4x to both sides, this cancels. Negative 3x plus 4x is just x minus 4 equals negative 5. If I add 4 to both sides, I end up with x equals negative 1. So now that I have that, I can take that and take this x equals negative 1 and plug it into either of these equations. I'll choose the top one. Y equals negative 3x minus 4, which again, if I put in negative 1 for x, substitute that in, that's going to be y equals negative 3 times negative 1 minus 4. That's going to be the same thing as negative times a negative is a positive, so that's 3 minus 4, which equals negative 1. So for this one, my x is going to be negative 1 and my y is going to be negative 1, so my solution is going to be negative 1 comma negative 1. This is the one point that works for both of these. And we can try it. We'll do it in a different color so you can just see that that's the case. If I do this one here and plug in negative 1, I'm going to get negative 1 equals negative 3 times negative 1 minus 4. That's negative 1 equals 3 minus 4, which is equal to negative 1 equals negative 1. Yep, this blue one right here, that works. And again, if I did this right, then this second equation, which I'll do in red right here, using negative 1, should also work out. Let's see. If I have y is negative 1, so that's negative 1. Negative 1 equals negative 4 times negative 1 minus 5. That's negative 1 equals 4 minus 5, which equals negative 1. So I end up with negative 1 equals negative 1, which of course is true. So this one is also true. So we've double checked to make sure that indeed this one right here, that negative 1 is the solution, and in fact the only solution that's going to work for both of these equations, this one and this one. Alright, for number 3 and 4, once again we're going to solve using substitution. And when I look at this one, I have that y is isolated here. Y equals this thing here. So if I put this, I'll put this one in red. If y equals this here, then this y here is the same one here. So if I write this one here, I'll write it in blue so you can see the difference. So if I take 3x plus 4 and I'm going to use this y, and that equals 5, well, then I can just say it, that's 3x plus 4, and what is y? Well, in the second equation, if I substitute that y in, that's 2x minus 7. So I've just written this blue equation, this top equation here, written this blue equation here, except where the y is, I've substituted in this value here, which is in red. And so now I can just solve this. I have 3x plus, I have to distribute. 4 times 2x is 8x. 4 times negative 7 is minus 28. And that's going to equal 5. 3x plus 8x is 11x minus 28 equals 5. If I were to add 28 to both sides, I get 11x equals, this cancels, 11x equals 33. Divide both sides by 11, and I get x equals 3. Alright, now that I have a value for x, I can take it and plug it into either of my equations. I'll do the top one, the blue one here, so I'll just do this in blue. So I have 3x, so that's 3 in this case. 3, if x is 3, I'm going to substitute that in. Plus 4y equals 5. That's 9 plus 4y equals 5. If I subtracted 9 from both sides, I end up with 4y equals negative 4. Divide by 4, and I get y equals negative 1. So my point is going to be 3, negative 1. If instead of this, if I had taken the x and substituted into the red one, I would have gotten, okay, well, y equals, that's 2 times, I'm substituting in 3 minus 7. That's the same thing as 6 minus 7, which equals y equals negative 1. So in either case, whether I did the blue one, I got y equals negative 1. Whether I did the red one, I got y equals negative 1. And of course, for my x, I got 3. So my final answer is going to be that the solution for these two equations is the point 3 comma negative 1. That's my answer for that set of points. Or excuse me, that set of equations. All right, problem number 4, I'm going to do the same way. I've got this equation here in blue, where y is equal to negative 4x minus 4. And then I've got this equation here in red, which doesn't have anything isolated. But if I rewrite this one as 4x plus 3y, and the y I'm going to use is the one in blue, this one right there. But the y's, of course, are going to be the same if the solution is if I come up with a system of solutions, minus 4. Okay, so I've just rewritten this equation in red here, except I've put in the blue y. So now I can just substitute that in. So that's 4x plus 3 times y, which in this case is going to be negative 4x minus 4. And that whole thing is going to equal negative 4. So now I can just solve this to try to figure out what x is. So I'm going to have 4x. I got to distribute my 3 times negative 4 would be negative 12x. My 3 times a negative 4 is going to be minus 12. And that's going to equal negative 4. If I combine my terms here, 4x minus 12x is negative 8x minus 12 equals negative 4. If I add 12 to both sides, I end up with negative 8x equals positive 8. If I divide by negative 8, I get x equals, a positive over a negative is a negative, so negative 1. So now I've got x equals negative 1. I've got to figure out to solve for y. So I'll do that in the blue equation here. Again, I could choose either one. I'm just going to choose the top one. So I'm going to say y equals negative 4x. Well, what's x? Negative 1. So negative 4 times negative 1 minus 4. Multiply that out. That's y equals a negative times a negative is a positive. 4 minus 4 equals 0. So y equals 0. Okay, and I don't have to do this, but just to double check, I could have, again, chosen the red equation instead and plugged in my value of x for negative 1. So if I do that, I'm going to have 4 times negative 1 plus 3y equals negative 4. That's negative 4 plus 3y equals negative 4. If I add 4 to both sides, this cancels, and I'm left with 3y equals 0. If I divide by 3, the 3's cancel, and I'm left with y equals 0. So again, you don't have to do this twice. I didn't have to do it in blue and red. I'm just doing it to show you that either way you do it, you're going to come up with the same answer. In this case, y equals 0. So if I've got x equals negative 1 and y equals 0, then the solution, the point solution to this systems of equations is going to be negative 1, 0. All right, for equation number 5, you'll see that I have a y with no coefficient in front of it. It's just one y. But I haven't isolated the y. So if I were to, we'll do this one in red. If I were to take this equation here, negative 2x plus y equals 4, and I were to add 2x to it on both sides, now I end up with y equals 2x plus 4. Now that I have that y, I can go back to my first equation, which I'll put in blue, this one right here, and I can rewrite it as 4x plus 3 y's, and I'm going to use the red y for that one because, again, they're going to be the same, but you'll see that I'm just going to plug that in, substitute that in, and that equals 2. So I just copied the blue equation. So now it's just 4x plus 3, and what is y? Well, y is 2x plus 4. 2x plus 4, and that equals 2. So now I just have to distribute. So I've got 4x, 3 times 2x is plus 6x, 3 times 4 is plus 12, and that equals 2. Can combine my terms. 4x and 6x is 10x plus 12 equals 2. If I subtract 12 from both sides, those cancel, so I'm left with 10x equals negative 10. If I divide by 10 on both sides, I get x equals negative 1. Okay, so now I know the x value, and to find the y value, I'll just take this equation here that's in red, this y one, and I'll say, well, y equals 2, x is -1, so 2 times -1 plus 4. That's the equivalent of -2 plus 4. That's the equivalent of 2. So y equals 2. And so if the solution is going to be x equals -1 and y is 2, then the point is going to be -1, 2. That is going to be my solution for this systems of equations. For number 6, I have this x value right here that is isolated, or it's not isolated, excuse me, it has no coefficient. I can easily isolate it here by rewriting it as, instead of saying x plus 4y equals -6, if I were to subtract 4y from both sides, I would get x equals -4y minus 6. Now if I take my second equation, which I'll put in red right here, that equation is just 3x, and I'm going to put my x in blue because I'm going to substitute in that blue x. 3x plus 2y equals 2. So that's the same thing as 3. And what is x? Well, we said right here that x is -4y minus 6. So I'm substituting that in. Take that plus 2y, and that equals 2. So now I just have to distribute. So 3 times -4y is -12y. 3 times -6 is -18. Plus 2y equals 2. If I combine my -12y and my 2y, that gets me -10y minus 18 equals 2. If I add 18 to both sides, I end up with -10y equals 20. If I divide by -10 on both sides, I get that y equals a positive over a negative is a negative, -2. Now that I have what y is, I can go and plug it into either of the equations. I'm going to do it to the top one, this one in blue here, this one right here. So I'm going to rewrite this as x plus 4. Well, what's y? Y, it says down here, is -2. That equals -6. So that's x plus -8 equals -6. If I add 8 to both sides, those cancel, and I'm left with x equals 2. So if my equation, or if the solution to my systems of equation is the point where x equals 2 and y equals -2, then the final solution is going to be 2, -2. And that's going to be my one point that is a solution to both of these equations in number 6 right here. All right, for problem number 7, I'm going to be using substitution again, as it's been asking me to use. I'm going to substitute like I have in the past, except unlike the other ones, I don't have any equation, or I don't have any term here that has either an x or a y where it doesn't have a coefficient, where it's just x alone or y alone. I've got -2 and 2 and 2 and -3. So what I'm going to do is I'm going to first create a thing that's easy to simplify. I will do it with this one right here. I'll put it in red. So I'm going to rewrite this down here as -2x plus 2y equals 2. Now, if I were to add 2x to both sides, I'm going to isolate the y, so that cancels. So on the left side, I have 2y equals 2x plus 2. And then if I divide by 2, and I do that to all my terms to balance, those cancel, that cancels, and that cancels. So I'm left with y equals x plus 1. So I'm going to use the equation for the red one of y equals x plus 1. And in this blue equation here, now that I have a value for y here, I'm just going to rewrite the blue equation as 2x minus 3y, and the y I'll put in red here because I'm going to substitute that in. 3x minus 2y equals negative 5. And now I'm going to substitute my value of y in here, which I've just created over here. So that's 2x minus 3, x plus 1. Oops, sorry, I put that in red. That was the whole point. X plus 1, and that's going to equal negative 5. So now I have to just distribute 2x minus, make that in black, 2x minus 3 minus negative 3 minus 3, negative 3 times x is negative 3x. Negative 3 times plus 1 is minus 3, and that's going to equal negative 5. Now I can combine my x's. I've got 2x and negative 3x. That's negative x, or negative 1x, minus 3 equals negative 5. If I add 3 to both sides, I end up with negative x equals negative 2. So if I multiply both sides by negative 1, that changes the sign here. X equals a negative times a negative is a positive. So I have x equals 2. Now that I have x equals 2, I can go back and plug it into either equation. I'm going to choose the top one that looks easiest. So I've got y equals x plus 1. So that's y equals, if x is 2, 2 plus 1. So y equals 3. So now I have my x value of 2 and my y value of 3. So the solution to this, where I have both x and what that's going to work for both x and y, to work for both of these equations, is simply the point 2 comma 3. And I don't have any equation, or I don't have any variable that doesn't have a coefficient. I've got a 4x and a negative 2y and a 3x and a negative 4y. So nothing that is alone. So what I'm going to do is I am going to take this first equation, which I'll do in red here, of 4x minus 2y equals 10, and I'm going to isolate the y. So if I subtract 4x from both sides, I'm going to have those cancel. Negative 2y equals negative 4x plus 10. If I then divide by negative 2, and if I do that to one side, I have to do that to both sides, all the terms. The negative 2's cancel. I'm left with y equals a negative over a negative is a positive 2x. A positive over a negative is a negative minus 5. So now I've rewritten this top equation as simply y equals 2x minus 5. Now I can take this blue equation, this one right here, take this blue one and rewrite it as 3x minus 4y, but the y I'm going to use, I'm going to substitute that other y in, and as it says right here, that whole thing is going to be equal to 0. So that's 3x minus 4. Well, what is y? We said down here, y is just 2x minus 5. And when I do those two things together, add them up, they're going to be equal to 0. So now I can just distribute. I've got 3x here. Negative 4 times 2x is minus 8x. Negative 4 times negative 5 is plus 20, and negative times a negative is a positive, plus 20, and that's going to equal 0. And if I take 3x and negative 8x, that's negative 5x plus 20 equals 0. If I subtract 20 from both sides, that cancels, so I'm left with negative 5x equals negative 20. If I divide by negative 5 on both sides to isolate my x, those x's cancel, or those negative 5's cancel, and I'm left with x equals a negative over a negative is a positive, and 20 over 5 is 4. So x equals 4. Now that I have x equals 4, I can just go back and plug it into any of my equations up here. So I'm going to take, so I've got y equals 2x minus 5. So that's just y equals 2. In this case, we said x is 4 down here, so times 4 minus 5. So doing that whole thing out, that's just y equals 8 minus 5, which is y equals 3. So now if I have the x value of 4 and the y value of 3, then my solution is going to be the point 4, 3. That's going to be the solution to the systems of equations. This is the only point 4, 3 that works for both of these equations.